Hello, dear listeners. I am Emre Yılmaz. I am a senior student of the Department of Electrical and Electronics Engineering at İzmir Katip Çelebi University. Today, I will tell you about my joint project with Baylan Company. The name of my project is Microcontroller-based Wireless Communication System Design for Smart City Lights. Electrical energy consumption is overgrowing with population growth and urbanization. The increase in energy consumption brings with the types such as environmental, noise, and light pollution. Reasons for light pollution are street lighting, recycled lighting, and lighting made to decorate and parks and gardens. Street lighting illuminates the environment at night, increases the viewing distance, creates a sense of trust, and decorates the environment. However, unconscious and excessive lighting negatively affects nature and electrical energy consumption. This study focused on reducing energy consumption in light-emitting neon street lighting and detecting defective LED street lights. The design system consists of a LED luminaire, temperature and humidity sensor, ambient temperature and humidity, motion sensor for human density, in-plane switching display, and LED street luminaire, power supply, motor driver, and STM32 microcontroller. The microcontroller used in embedded system is programmed with the C programming language to enable the communication of the sensors and data transmission. It also consists of a LoRaWAN device, LoRa gateway, server, and application that enables the system to exchange information. Retrieve information such as time and date, display broadcast information, and store sensor data. Voltage control on the motor driver is done by pulse width modulation. In the design system, a long-range wide area network infrastructure was used for data transfer to server and the process reaching the processor from the server. The measured temperature and motion data, erroneous and non-defective information, and brightness information are transmitted by radio frequency, LoRa gateway by the LoRaWAN device. LoRa gateway has internet access. In this way, the data is transferred to the server. Radio LoRa broadcasts were made every 1 hour. It also informed the relevant institutions by broadcasting when the street light does not give light. Unlicensed frequency channels are used in ISM band. Otherwise, the radio frequency output power designed not to exceed the value that can be used without the need for a license. In this way, the cost of the system has been dramatically reduced. This system is used in ISM band with 868 MHz. LoRaWAN default and not class port is defined as class C. LoRaWAN adaptive data range is open. The LoRaWAN activation type is authentication by personalization. A user interface has been designed in C# programming language so that the user can access the data reaching the server. The data for designed application was taken from the database for Baylan Company. The application can send email to the authorized person in case of sudden change in the data. There are date, temperature, brightness, humidity, and motion variables in the application. This system aims to examine the relationship between the amount of the energy consumed by LED street light in different modes and the amount of energy consumed by sodium vapor street light in different periods, and the amount of energy consumed. LDR and motion sensor are active when the LED street light is turned on to save energy. The temperature and humidity sensor are always busy. When the system starts, it sends the make command to the server during the local time. If the local time does not reach the system, the make command is repeated at certain time intervals. When the local time goes to the processor, it controls when the LED street light will turn on according to the mode and day. When the LED street light is on, it lights up 100% brightness. At the same time, the motion sensor and LDR sensor start to measure. When the light intensity falls below specific value, the street light sends the LoRa terminal device to the server with information that the street light is malfunctioning. When the time is 12 o'clock at night, number of detected motions is evaluated. The brightness of the lamp changes and remains constant depending on the number of detected movements. As a result of the measurements, the data presented in Figure 4 and presented in terms of the current driven by street light at different brightness in the amps, the voltage used in volts, and the total power consumed in watts. The amount of energy consumed by the street light is different brightness is shown in Figure 5 every month. This study designed and tested lighting immediate diode street luminaire system with communication protocol instead of the sodium vapor street light. The brightness of the LED street light should be checked examining data received from the sensors connected to the system. The transfer of the data to the server was performed by LoRaWAN device, LoRa gateway. The LoRaWAN protocol can be quickly and successfully applied to transmit data and multiple systems. Based on the results given, no problems were encountered in the communication and stability of the system, and it has been shown to perform adequately. Machine learning methods can be used to improve wireless communication in case the proposed work continued or similar in the future. Thank you for listening to me. I wish you healthy days.